Hello Year 10 and welcome to Lesson 5 on sequences. Today we're going to look at quadratic sequences, but first we're going to go through the answers to the task from yesterday's lesson. So before we find the first 5 terms of our sequence, we should be looking at the coefficient of n in every case, because that will tell us what our common difference is. So in this case, we've got 1n, and that tells us we're going to have a sequence that's going up by 1 every time. And these should be the terms that you've got here. B, we've got 3, so we should have a sequence that's going up by 3 every time. C, there's a 4, so we should have a sequence going up by 4 every time. D, we're going up by 7 every time, and so on. It doesn't matter that this is the other way around. We've got a sequence going up by 9 every time, so the difference between each term is 9. Same here, it's 5. And then we've got 6. Then we've got a decreasing sequence. So here we're subtracting n. So this is going to go down by 1 every time. This one is an increasing one again, going up by 8 every time. Decreasing and going down by 4. Decreasing and going down by 2, and then increasing and going up by 7 every time. So question number 2, we've got the nth term of a sequence. It's a decreasing sequence and it's going down by 4 every time. The first term means that I need to substitute in a term number of 1. So n is going to take a value of 1. So 26 subtract 4 multiplied by 1. BIDMAS tells me to multiply first, so 26 subtract 4, which is 22. The third term then, 26 subtract 4 multiplied by 3. BIDMAS tells me to do the multiplication first, so 4 multiplied by 3 is 12, and then subtract. So the third term is 14. Fourth, 26 subtract 4 times 4, which gives me 10. And then the seventh, 26 subtract 4 times 7, and that's going to give me an answer of -2. Okay, so today's lesson, we're going to look at quadratic sequences, and ultimately we're going to be generating quadratic sequences from the nth term formula. That's all you're going to need to do with these. You're not going to have to find the nth term in the case of quadratic sequences. So first of all, we need to talk a little bit about what a quadratic sequence is. So here we've got the term number on the screen in front of us, just like we did for arithmetic sequences, and then n is our general term number. And here, quadratic sequences are all going to be based on the square numbers. So across the top, I've got a visual representation of the terms, and the terms themselves are going to be the number of squares that I've got in each case. So term number 1 is just going to be 1. Term number 2, 1, 2, 3, 4. Term number 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So term number 4 is 16. And those are giving me just the square numbers. Now here, if I wanted the term number to the term rule, you should be able to see that each time I'm squaring the term number to get the term itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the term number to term rule is that I'm squaring, and so my nth term is going to be n squared. Now something interesting happens here with the term to term rule. If I look at the first one, if I look at what I'm adding 3. And in the case of the second one, I'm adding 5. And in the case of the third one, I'm adding 7. So we do get a sort of a pattern, but it's not the case that we're adding a consistent amount every time. And when we were doing arithmetic sequences, I said to you that you have to be very careful not to just try the first 2 terms. And if you did this here, you might think that you had an arithmetic sequence where you were adding 3 every time, and you might then continue that, and that would give you the wrong answer. So you should always try to look for the differences between a few terms first of all, just to make sure you know what type of sequence you've got, because you won't necessarily be told in an exam question that you're dealing with an arithmetic sequence or a quadratic sequence. Okay, so what we looked at so far was the square numbers forming our sequence, and we talked about the fact that the nth term formula there would be n squared. But I'm now going to create a different type of sequence by adding a square, an extra square to each of my square numbers, and those are going to form the terms in my sequence. So term number 1 is 2 now, term number 2 is 5, term number 3 is 9 add 1, which is going to be 10, and term number 4 is the 16 plus the extra 1, which is 17. So this is still a quadratic sequence. It's still based on the square numbers, but instead of just n squared now, I'm actually squaring and then adding 1. So my nth term formula is square first and then add 1. So n squared add 1. And if I look at the term to term rule, you can see I'm adding 3, then I'm adding 5, and then I'm adding 7. So we're still getting this sort of pattern, but we certainly don't have a common difference. Okay, here is another type of quadratic sequence, and this time hopefully you can see I've got my squares and then I've taken a tile away. And that's true for this one as well. I've taken a tile away, but I would only have had one in the first place, so now I've got none. And so this is based on the square numbers again, for which the nth term is n squared. But my sequence now is the first term is a 0, the second term is 3, the third term is 8, and the fourth term is 15. And so this time I'm subtracting 1, and that's giving me an nth term formula of n squared subtract 1. And again, if I look at my differences, I've got add 3, add 5, add 7. So hopefully that gives you a little bit more understanding of quadratic sequences, where they come from, and what goes to make them up. You're not going to have to find the nth term formula for these though. You're just going to have to be able to generate a quadratic sequence from an nth term formula that you're given. So that's what we're going to look at next. So here's an example. Find the first 5 terms of the sequence n squared add 5. So the first term is 1 squared add 5, because of course n is representing the term number. So the first term n is 1. The second term is 2 squared add 5. The third is 3 squared add 5. Then 4 squared add 5. And then 5 squared add 5. Now I've got to just make sure I'm using BIDMAS here. BIDMAS has brackets first and then the I is for indices. In other words, I have to work out my indices here before I add 5. So I'm going to square 1, which gives me 1, then add the 5 to give 6. 2 squared is 4, add 5 gives me 9. 3 squared is 9, add 5 gives me 14. 4 squared is 16, add 5, which gives me 21. And 5 squared is 25, add 5, which gives me 30. And those are the first 5 terms of my sequence. Now, this should look familiar to you because we did graphs not so long ago, and we looked at plotting quadratic graphs, and we did that in a table. And you might have had plot the graph of y equals x squared add 5, which looks very similar to this, except we've got an x instead of an n. And we would have worked out a table looking like this. Now, this is essentially what we've just done over here, where instead of having a term number, we've got an x. And instead of having an n squared add 5, we've got an x squared add 5. But it gives us exactly the same terms, which we would then go on to plot and would give us a quadratic graph. The only difference is when we're using sequences, we don't tend to have to input negatives, which we do when we're doing the quadratic graphs. Okay, here's another example for you. Could you pause the video and have a go at finding the first 5 terms of this sequence? Okay, so term number 1, 10 minus 1 squared. Term number 2, 10 minus 2 squared, and so on for the next 3 as well. BIDMAS tells me I need to work out my powers before I subtract. So I'm going to have 10 minus 1, which gives me 9, 10 minus 4, which gives me 6, 10 minus 9, which gives me 1, 10 minus 16, which is going to give me negative 6, and 10 minus 25, which gives me negative 15. And those are the first 5 terms of my sequence. Here's another example for you, slightly different now because we're not just adding 3, we're adding 3n. So I would like you to pause the video and have a go at doing this for yourself and then start it to check that you've done it correctly. Okay, so you should have 1 squared add 3 multiplied by 1, 2 squared add 3 multiplied by 2, 3 squared add 3 multiplied by 3, and so on. And BIDMAS tells you to do indices and then multiplication before you add. So that'll be 1 add 3, which is 4, 4 add 6, which is 10, 9 add 9, which is 18, 16 add 12, which is 28, and 25 add 15, which is 40. And those are the first 5 terms of my sequence. Okay, slightly harder again, but I'd like you to pause the video and see if you can generate the first 5 terms of this sequence. Okay, so you should have 1 squared subtract 5 multiplied by 1 add 3. So I've just substituted in for my n's a 1. Then I'm going to do the same for the second term, the third term, the fourth term, and the fifth term. But this 3 isn't connected to an n, so it's just add 3 every time. That doesn't change. Now BIDMAS tells me indices and multiplication before I subtract and add. So I'm going to have 1 subtract 5 add 3, which gives me negative 1. Then 4 subtract 10 add 3, gives me negative 3, and so on. It's really important to put these steps in so that you don't make a mistake. And those are the first 5 terms of my sequence. Here's a final super tricky one. So pause the video and see if you can work this one out. You're only being asked to find the 10th term. Okay, this is trickier again because we've got 3n squared, and BIDMAS tells us we've got to work out the indices first before we multiply. So I've substituted in 10 for n in every case, and now I need to do 10 squared before I multiply by 3. It's really important you don't do 3 multiplied by 10 and then square. That will give you the wrong answer. So 10 squared is 100, and then I'm going to multiply that by 3. 10 multiplied by 10 is 100, and then I've got to subtract 1. And now multiplication before additional subtraction. So I get 300, add 100, subtract 1, which gives me an answer of 399. Okay, so here is your task for today. You have to find the first 5 terms of each of the following quadratic sequences. Starts relatively straightforward, gets a little bit tricky towards the end. Just remember, for example, with question 3, you have to square n before you multiply by 2 because BIDMAS tells you to do the indices before multiplication. So pause the video and show all of the working in your maths books.